Now, ionic compounds are put together by electrostatic attractions. Covalent compounds are put together by a sort of a quantum mechanical effect, where the bonded atoms are trying to attain a noble gas configuration. So there's fundamentally different things putting together these two kinds of compounds, and it's not surprising that there are some important differences that you can see in the lab between these two kinds of compounds. What experimental evidence do we have, anyway, that we have an ionic compound? Well, the big one is an ionic compound is made of ions, right? And an ion is a charge, and electricity is moving charges. You're moving a charge from one place to another. So if you can conduct electricity through the compound, then you have an ionic compound. So if I've got a salt crystal, it's got a bunch of sodiums packed together with chlorides in a solid. You have this regular lattice. And let's say we try to conduct some electricity in it. Now, for electricity to be conducted through this solid crystal, you're going to have to be able to push one of these ions through. But these are all locked in place. In an ionic lattice, there isn't a lot of movement of the ions through the lattice. They mostly just vibrate around a given point. So because you can't move the ions, you can't get any moving charge and you can't conduct electricity. So the solid doesn't conduct, but if you melt it so that you've got the chlorides all free from the sodiums, they're floating around free. They can move past each other now. They're not locked into place. You can get it to conduct electricity. You can get those charges to move. What you can do is take two electrodes, two metal plates, put a negative charge on one and a positive charge on the other, and you will see that the negatively charged ions will migrate towards the positively charged plate. And ditto for the positively charged ions, they'll go after the negatively charged plate. And because you have moving charges here, the liquid does conduct. So when you melt an ionic compound, it will suddenly become very conductive of electricity. You'll be able to conduct electricity through it. How can you tell? You can't see the little ions. How can you tell that charge is being carried between these two plates? Well, maybe you've got a battery hooked up to this, and hooked up to the battery, maybe you have a little light bulb, and these ions are completing the circuit. They are carrying charge across the void between these two plates, and you'll see that the light will light up. Now, molecular compounds, when they're in the liquid form, don't do this. If you dipped these two charged plates into a molecular compound, there are no ions in there to carry the charge, or at least not many. So you won't see the light up. You will not see conductance on a level like you see with a melted ionic compound. Now, ionic compounds can also conduct electricity in solution. If you take this salt crystal and dissolve it into water, what happens is the water molecules, being polar, will swoop in and grab ions out of the lattice and carry them off. Now water molecules are polar. That OH bond is polar. There's a negative end on the oxygen end because oxygen is the more electronegative atom. And it'll surround the sodium and carry it off, and it won't be able to go back to the crystal again. They'll do the same thing with the chloride, except this time the hydrogens will stick to the chloride because that's the positive end of the water molecule. So essentially what you have is an ion with waters attached to it. And now these are free to move, just like they are in the melted salt. And I can go ahead and put a solution in there instead of a melted compound. And because these things can move freely, you'll see conductance. So if you take a spoon of salt and you put it into some water and stir it up, and you stick a gadget like this into it, where you've got two charged plates, you will see that the solution will complete the circuit and the light will light up. So, you know, salt water conducts electricity a lot better than just regular water does. Regular water, I mean just H2O, is a molecular compound, but it does conduct electricity a little bit in liquid form. Why? There's a water molecule. Here's another one. Sometimes water can react with itself. This positively charged hydrogen can go and stick on to the negatively charged oxygen here. And you can get this happening sometimes. Get a negative charge left behind and a positive charge here. So this whole thing here has got a positive charge. We don't have the whole Lewis structure for that. Well, I'll finish it. Later on we'll draw Lewis structures for things like this, but you're getting something like this happening. Now you got a negatively charged broken piece of water. It's called a hydroxide ion, and a positively charged piece of water. And now you can conduct electricity just a little bit with regular water. But this happens very rarely. 1 out of every 10 million water molecules will be in a broken state like this. So it doesn't, a molecular compound like water does not conduct electricity on the same level as an ionic compound. An ionic compound will conduct a lot of electricity. What's another difference? Well, if you have this ionic lattice, it's very strong. There's a lot of ions in very close contact, and you can pack them very tightly. You need a lot of heat. You need a high temperature. To pry all those ions away. Because when you melt it, you're prying the ions away from each other so that they can slip past each other. And we can say that if you've got an ionic compound, it's got a high melting point, a relatively high melting point. That's the temperature that it melts at. It will have an even higher boiling point. For molecular compounds or covalent compounds, you can call them either molecular compounds or covalent compounds. Same thing. You get a lower melting point. MP is the abbreviation for melting point. A lower boiling point. So using these two properties, electrical conductivity and melting point, you can do a fairly good job of distinguishing ionic from molecular compounds. And you're going to do that in the Pivot Lab that is right after this lesson.